we have draw the Lewis structure for the nitrate ion NO3. Assign the formal charge for the central atom nitrogen, and then it's asking what is that formal charge. So with that being said, let's go ahead and write this question down: NO3 minus Lewis. Okay, and then we'll also answer the formal charge of the nitrogen. So nitrogen, being on the 15th column, has 5 valence electrons. Oxygen, being on the 16th column, has 6 valence electrons. So with that being said, we have 5 plus 3 times 6, because there's 3 oxygens. So right now that is 18 plus 5. That is going to be 23. And then we have this nice minus here indicating we're adding an extra electron. So we're working with 24 electrons total. So let's go ahead and draw with nitrogen in the center, not just because the question says so, but also because nitrogen just so happens to have the most unpaired electrons in its atomic form. So we have N, and we have the 3 O's, and supposedly it ends up being 1 minus. So let's just go ahead and now fill in the octets for everything here, or at least attempt to, because right now each oxygen is sharing one of its 6. So 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6. Okay, let me just reposition this. There we go. And now the nitrogen is sharing 3 of its 5. So we have 4 and 5. So with this being said, there are many ways this can go. But first we want to take care of the issue of the extra electron. For this case, I'm just going to go ahead and give it to one of the oxygens, because typically they would have more of an affinity towards the electron, aka the electronegativity, to where there's no point really of putting it at the nitrogen. And also we're filling an octet rule conveniently. Okay, so there we have it for that. Okay, so that one's taken care of. But we still have at least 2 unpaired electrons. How are we going to approach that? That is a very good question. So for this is where it gets a little bit tricky, because we don't want to break the octet rule. We're going to have to now form a bond with one of the oxygens, and we're just going to literally throw the other electron to the other oxygen. The reason why I say that is because if I try to form a bond with the other oxygen, I'll end up with this shape. And nitrogen, although it would love to, cannot do that, or else it would break the octet rule. So this is a no-no. Can't do that. In this case, when I now form a bond and throw the other one, I still follow the octet rule, and hopefully most things will be satisfied to where they can also follow the octet rule. So now I have this. Okay, so now we're going to see, does it follow the octet rule for everything? Yes, it looks like it does, which is a very good start. Do we have 24 electrons? We have 4 bonds and 3, 6, 7, 8, 8 lone pairs, so that's 16. So 16 plus 8, we do indeed have 24 electrons. Also a good sign. Now what is this formal charge they speak of? So nitrogen, funny enough, for it to have a formal charge of 0, like a net 0, it needs to have 1 lone pair and 3 bonds. This nitrogen here in this picture has 4 bonds. It has replaced a lone pair with a bond. When you do that, when you replace a lone pair with a bond, you become more positive. So this nitrogen actually has a plus. And now you're probably wondering, if this has a plus, how does this whole molecule have a negative charge? Well, let's check the formal charges of the oxygen. Oxygen typically would just be 2 bonds and 2 lone pairs. This is based off of the valence electrons, just in case you were unaware, because nitrogen has 3 unpaired electrons, and that's how it would form 3 bonds. and oxygen only has 2, hence how it only formed 2 bonds. And as you can see, only one oxygen has 2 lone pairs and 2 bonds. The other 2 oxygens have 3 lone pairs and 1 bond. Now we're doing the opposite of the nitrogen. When you replace a bond with a lone pair, you become negative. At least you're taking a negative step in that direction. So with that being said, you can now see that the oxygens, there's 2 negatives and 1 positive, hence how the nitrate ion has that just 1 minus for its ion, this molecular ion. So with that being said, they ask, what is that formal charge for nitrogen? And that's what we just did. We assigned a formal charge, and to the nitrogen is +1 formal charge. Now, mind you, this does have resonance structures to where things do move around, but at the end of the day, most likely the nitrogen will remain that +1, because there's no way we can reorganize it to where nitrogen becomes neutral and it doesn't break the octet rule, because it needs to be able to form those bonds with the other oxygens on the extremities. Okay, and if I were to move certain things out, then it's no longer following the octet rule. So that being said, this is what they got. Perfect. That's the picture we have right now. 2 negatives, 1 positive, and the formal charge of nitrogen is indeed +1. So this is perfect. So move on to now question number 7. We have